All right, in 8.1, we talked about mean. Now in 8.2, we're talking about proportion. All right, so suppose that a random sample of size n, so it's still a sample, right, obtained from a population in which each individual either does or does not have a certain characteristic, the sample proportion denoted by p hat. So, stats is a lot about the symbols. And so then that's our symbol for proportion is going to be this p hat. Is given by, what happens when you find a proportion? Any proportion out there ever, what do? Part divided by whole, and that's exactly what's happening. So x that we're trying to find divided by our n, where, and then it's defined right here, x is the number of individuals in the sample with that specific characteristic, the specific thing we're looking for, the part, the sample proportion p hat, is a statistic that estimates the population proportion P, right? We already learned that N is the sample size. X is out of this sample, how many have this specific characteristic, right? That's your X is out of the total sample that have the characteristic you're looking for. That is my sample proportion is my P hat, okay? So there are our variables. So let's look. The Harris Poll conducted a survey of 1,200 adult Americans who vacation during the summer and asked whether the individuals plan to work on their vacation. Of those surveyed, 552 indicated that they do plan to work on vacation. Find the sample proportion of individuals surveyed who plan to work while they're on vacation. All right. So what is X in this instance? The 552, right? So X is 552. What is N? Yep, it's 1,200 because that's how many were surveyed. That's the total. So P hat in this instance is X divided by N. In this instance, 552 divided by the 1,200 total. If you do this division, let's take it to 2 decimal places. What do you get? I have 0.46. Is that what you get? Nice. So we can write this as the Harris Poll estimates that 0.46 or 46% of adult Americans who vacation during the summer plan to work. So the Harris Poll estimates that 0.46, I'm putting a 0 in front, 0.46 or 46% of adult Americans plan to work on summer vacation. All right. Do you work on summer vacation? I usually do because I usually teach in the summer. So if I go on vacation, I'm working just because it's online. But so I guess I'm a statistic, right? That's what we're learning here. All right, so let's look at this next one. Based on a study conducted by the Gallup organization, 76% of Americans believe that the state of moral values in the U.S. is getting worse. So describe the sampling distribution of the sample proportion for N is 10, 25, and 60. All right. So here is this setup, right? 1 is equal to success. I don't know if you can even see that. There's ones and zeros. 0 is failure. All right. So 76% of Americans believe that the state of moral values in the U.S. is getting worse. Yes, I agree. No, I don't. Success, failure, right? So that's kind of how that plays out. This is just data that's put out there, right? So we're just looking at this big pile of data. Now, based on this data, so this one is set up as 10. So we have a sample of 10, 25, and 60 on each sample. So this is sample here where N is equal to 10. And then you can see that data. Then they do another one for part B here where the sample size is 25, or N is 25, and then you have samples with 25 individuals in it, right? Like what we did in the last section. We're just changing that up. All right, so I'm going to squeeze this together here a little bit. And look at what kind of data we're given. Can you see this? I'm going to make this bigger because I feel like you can't see it very well. So the sampling distribution of p hat, n is 10, p is 0.76. Now, why is that 0.76? Where'd that come from? Yep, 76% of Americans. So when we write P, we're not writing it as a percentage. You always change it to a decimal. So that P here is 0.76 that we're working with. Okay, so squeeze this back in a little bit and come up here. So we have our sampling distribution here of P hat when N is 10. I'm going to squeeze this together. We see what's happening when N is 25. P is still the same, right? P is the same and N is 60. Look at what's happening with our distribution here. What's going down? What do you see? Yes. So here, this is skewed just a little. If we were to follow the actual data, it kind of looks like that, right? Here we're following the actual data, kind of looks a little like this. Here we're following the actual data, and it's actually following my data. So shape, center, spread, we're going to look at the exact same things here. Shape, center, and spread. So looking at the same things. Look at our shape. As the sample size increases, what do you see about the shape? It becomes more normal, right? As the sample size increases, the shape becomes normal. Nice. What about the center? What do you see is happening here? Look at these numbers. Right? So as we're looking at this, do you see what's happening? So where is about the center of these? Because as you're going through here and you're trying to set these up, do you see our center looks like it's all about the same? So the mean of the sample proportion, equals the population proportion. So it's about that same. So right here at the center, like where we're looking at the center of this data, as you've got this, it's about 0.76. Look at this center. What is it? About 0.76. Where's this center? Halfway between here. I'm doing a terrible job of drawing a line. That's what's going down. Okay, what about the spread? What do you see happening with that? Yeah, so look at what's going down here. This one is 0.4 to way past 1 over here. This one is 0.4, but there's really not anything happening back there, right? So we're kind of bringing it in a little bit more. This one, we don't even have a 0.4 on the data because it's bringing it in even tighter to that 0.1. So as the sample increases, what happens to the standard deviation? If the data is getting tighter, what does that tell you about the standard deviation? That it decreases. Yes. So the standard deviation decreases because that's tighter data, less variation, smaller standard deviation, right? As the sample size increases. The same thing that we were seeing with the mean is happening here with the proportion, right? Okay, nice. So really, it's just, we're doing basically the same thing that we did here in 8.1, except we're talking about a proportion now instead of the mean that we have, all right? So, but the mean of the sample proportion that we're going for That's where we're going to get that population proportion.